so this is part 2 of piecewise functions that we've been working on 4.2 in the book. We're going to start on page 26 here. And so now we're talking about graphing these piecewise functions. So the first thing we're going to do is we're just going to graph a piece of a function. And so we're used to graphing a line like this 2x plus minus 3. We're given the y-intercept and we have the slope. And if we were going to graph that normally, right, we could just go the y-intercept, -3, and put a point, and then we go up 2, over 2, point, point, and so on and so forth, right? And then we could connect all with the line. And so it would look something like that, which is great. But in this case, right, we only want to look at part of this line. Well, what part do we want to look at? We want to look at the part that goes between -2 and x of -2. So again, that's always the domain where x is -2 and the x of 4. So you can see here, the only part we want would be the in between these two green lines. So if I highlight that green, it's going to be this part here. And so now, if I look, I'm going to try to erase some of this purple, right, which is okay at the moment. One way to do that is we know what the x's should be, right? We know we have x of -2 and an x of 4. So if we plug in x of -2 into the equation here, what y should we get? Well, -2 times 2 is -4. -4 minus 3 is -7. So that will be 1 point here. So -2, -7. That's that point there. When I plug 4 into the equation, I should get 2 times 4 is 8. 8 minus 3 should be 5. So we get 4, 5, which that's the other point that we have. And I can make both of these points solid, filled in, because of the fact that they're both brackets. Now I just connect those 2 points because, as you guys learned in geometry, right, 2 points make a line. So it's pretty straightforward there, and you can see that I'm having to mess around with the computer a little bit to just make sure the line fits, but there you go. Right. So what it asked you for is it didn't ask you for that whole line with arrows on the Antonio goes on forever. It was just asking you for the little part there that was highlighted in green. So why don't you try this one here? Okay, so it's giving you a line. Okay? It gives you that other equation here. So what I would say is if you would like, pause the video, try to graph this one on your own, and then start the video back up and see how you did. So if you tried this on your own, you can go ahead a little bit, but I'm going to look at this. So here is our domain. Okay, now we're going to want to see this domain. So I always highlight the ends of the domain, right? So this one is 1, right? X, when x is 1, that's going to be where it starts. And then the other one here is, okay, we're just going to look at infinity. So I'm highlighting off the graph here. So I know this is 1 and infinity, that's what I want to see. And so here, if we say, okay, x is 1, let's plug 1 in. 1 times 3 is 3, 3 minus 2 is, sorry, 3 minus 5 is -2. So there's going to be a point there. Again, bracket means you fill it in. Now there's 2 ways to go about this. I know the slope of this, so I could just go up 3 over 1, up 3 over 1, up 3 over 1, and so on and so forth. That will work. Or you can choose another point to plug in, right? You could choose the point 5, and that would be 15 minus 5, which is 10. And I have that point 5, 10, which I found from doing this. Okay, the one key about going to infinity goes on forever, right? So what we would do is we would start at this 1, and we are going to infinity, which means we need an arrow, because infinity is forever. So, right, as we graph that, it would look something like that, right? Where we have, let me see if I can get that line to behave a little bit there. It's not going to, but we can say, okay, that line would have started there and continued on. That's just the computer not being able to get right to that point there. So you can see, okay, we'd start at this point. Again, that's the closed dot. The infinity means the arrow goes off. So now let's look at page 127, and we're going to try a whole piecewise function. So this piecewise function has three parts. Okay. And so the first thing we want to do is let's rewrite this in interval notation. So rewrite in interval notation. So x is less than -1. So that's negative infinity, -1. It was not equal to, so it gets a print. Then we get this one. -1 is less than or equal to x. So the smallest x could be is -1 with a bracket to 2. Less than, and x is less than or equal to 2. And then finally, 2 to infinity. Right? So hopefully you figured that out. Now, what I would do if I were you is I would use each of these and use a different color. So however many pieces you have, that's how many colors you want to use. So first, yellow is going to be x, right? That's from negative infinity, so off the graph somewhere, to -1. And so, again, these are x values. Can't stress that enough. They are x values. And, okay, if I plug -1 in, -1 and into the x is just x. It's -1. So there is a point there. And should that point be a closed dot or an open dot? Well, it should be an open dot because that is a parenthesis. Now, I can plug in another point to x, like if I plug in -5, right? Well, if I plug in -5, that's just -5. And since it's going to infinity again, this needs to be a, and so we'll just leave it there. Oh, I'm coming in, just make sure it fits right there. Hopefully, there we go. So that's the first. Now, I'm going to do this for each part of this function. So now in the green, okay, green. So green's going to start at -1 and go to 2. So starting at -1, going to 2. So -1, okay, so let's plug in -1. -1 plus 1 is 0, and that's a closed dot. 2 plus 1 is 3. Going to be a dot there. And now we're going to connect those with another line. Okay, closed dot. And then finally here, look at this last one. -1, so from 2 to infinity. And, okay, well, that's always going to be -1. So that's just meaning, okay, there's going to be a open circle there because there was a parentheses with the 2. And then a solid line just running along when y is -1 with an arrow at the end because it goes to infinity. And there you just graph your first piecewise function. Now let's fall down. Is this actually a function or is it just a relation? Well, remember we have the vertical line test where if you hold your pencil or finger vertically across and as I scroll across, are there any x values that have 2 y's? And in this case, the answer is no, right? There's only, no, is this a function? Yes, because 3x only has 1 y. So the answer there is yes, it is a function. These here, they're in here because of the fact we have one closed and one open means it only hits that function at one point, not both. Okay. Again, as we did in the last video, what happens when f is 3? So if we look, when f is 3, right here, oh, y is -1. And you can do that by plugging in as well. When f is 2, this one's interesting, right on that dot, what are we going to see? Well, it's not going to be there. It's actually going to be here where y, the y value is going to be 3 there. So now let's move on to page 128. So here's another example. I want you to pause the video, try this one on your own, and then restart the video to see how you did. Okay, so you can see I've completed the problem here. First, I changed it into interval notation. Okay, again, I didn't like that here we started with -infinity on the bottom. So I rearranged it and rewrote it over here in the correct order that I think. So I would move this whole term first, middle term gets to stay, and the bottom subfunction goes the top here moves to the bottom for me. And that's, I put it in order of subdomain. Right? The interval notation. Start at -infinity or the smallest at the top as I work right to left to right and down I get to the largest at the bottom right. Now you can see the highlighting and how I graphed it there. Now, okay, it is a function, again, because as I highlight, no x goes to 2y's, and there -3 is -6, and f of 2 is 4. So those are kind of the two example problems here. So now you should have some time. Hopefully you can start on your homework and get some good practice in. So let me know if you have any questions, and I hope this helped.